Hello everyone, welcome to my new video. This video will be finally about the Proxxon MF70 and main changes that I was made for this milling machine. About the engine, about the spindle, about the cross table that I'm using, about the height of milling that is possible with this machine at the moment. And as you know, initially this machine has quite small flexibility with the mills that you could use. It's just up to 3mm mills, and this is kind of problem because at the same moment it's the rotation speed is very high and mill is very small. Of course, for the small mill you need a higher rotation speed, but at the same moment, if you want to work with the steel or work with something harder than aluminum, it works not very well. I would say it's not works at all. I always want to have possibility to work with steel as well on this small milling machine that I'm using on just regular working table in the flat where I'm living, so that's why I will start modifying it. The first modifications that I was made was about the engine, and now I will disassemble everything here and show you in comparison what it was and how it became. When I did all the modifications, I was trying to make the overall view of the milling machine as original as possible. So as you can see, everything fits into the original body of the milling machine, and everything looks like it was initially from the manufacturer. These are the cover for the milling head. It's just a plastic cover, 4 screws and nothing more. Inside the milling head I have controller of the engine. Also here's the spindle and belt. Let's take a closer look. As you can see, also I'm using belt drive, and here's the engine. This belt is the belt and big gear is from the radio control car, on-road radio control car. This gear I made by myself, and I think I will still continue making these gears. I wasn't found anything that fits for me. The regulator is connected on top of a spindle. It's a top of spindle. And now I will remove all the electronics out from the milling machine. All the electronics connected to the aluminum piece. I was also made it by myself to connect the engine, to connect engine controller, and it's connected to 2 original holes that was initially used in the Proxxon to hold the cable. Here I have a connection of lights that I have on the bottom, and connection of engine controller. Here is all the electronics. You see a lot of dust out from the belt. It's always like this here. I don't know, maybe it's because this gear is not perfectly made, maybe belt itself, but I always have this dust inside. So I'm not worried about that. These are already third engine that I'm trying to use with this milling machine. It's engine with 860 kV. It means that at the end I have up to 3000 RPM on the spindle. It's 1:3 gear ratio at the end, and engine rotates up to 10,000 RPM. So a bit more than 3,000, 3,300, or near that maximum. But at the same moment, I could use it with like 1,500 RPM on the spindle, and it's almost not lose power. Previously, I was used also outrunner engine, but outrunner engine is noisy. Also, you could take a look on other my video where I'm actually replacing the outrunner engine with this one. And before that, I was used another one in-runner engine that had 2,200 kV, but it was too fast for what I want. This engine is working from 12 volts. As a power supply, I'm using just a simple 12 volt power supply, and actually everything is working very good. Let's compare with original electronics from the Proxxon. Originally in this machine we had 220 volt engine brushed with the brushes, and very small controller for the engine, and that's it. It's also possible to use, and even possible to change to the same engine, so you could skip changing of the engine. They are pretty the same sizes, so it's possible to use original electronics as well. But it will be a problem to mount somewhere this power supply for the engine. Of course, you could find a place where it could be mounted, but at the end, for me, this one is the solution. It not looks very nice here, but nevertheless, it's what I'm using. Okay, let's move forward to the next modifications. Another one very interesting modification is actually the spindle itself. So I will remove it now, and you will see how it's made. These are the gear that I'm using. Here I have the ring with which I'm compressing the bearings. So I don't want to have a play of the spindle inside the bearings, and that's why with this ring it's possible to compress the bearings. I will now remove it. Now the spindle itself, it moves down quite easy. Here's the spindle. As you can see, it's just regular ER11 spindle, so nothing special, just a regular nut, regular spindle with 8mm shaft. To use bigger shaft here, I don't think it's will have some benefit. I have a bit of scratches here, but it's not goes more. It was because of initially I made wrong placing of the bearing, and bearing was stuck and it was scratched the shaft, but it still works fine. And two bottom bearings that are in original Proxxon places where they was initially, and they are working well. Also, we could compare with the original Proxxon spindle. In original construction, we had much smaller spindle because engine is mounted directly on the spindle in the front place. So here is the spindle and engine on the top. Also, these are 10mm shaft with 10mm bearings that are a bit bigger, and the compression pipe, or how it says, how to tell it, with which that are inserted between the bearings. I didn't have these pipes between my bearings, but I have 3 bearings on the spindle. And let's go to the bearings. I have one more bearing in the place where engine was initially mounted into exactly the same mounting points of the engine, of the original engine. I was mounted the plate with bearing. It's a top bearing. And just 2 bearings replaced in the body of the Proxxon machine. More interesting part here is that I have rotation speed change also in the place where it was initially made with the Proxxon, and also switch that are initially in the place where it was initially with the Proxxon. I was used the rotation speed controller that I using as a servo tester for the electronics. And let's move forward with the next part. Next piece that I was changed is the vertical lead screw. It was one of my latest changes, as well as this rail protection. Originally on the Proxxon we have quite short lead screw, and if it's mounted here, the bottom position of the milling head is like this, and they have a very high distance between the table and milling head. So that was basically one of primary reasons to replace the initial lead screw that was with the Proxxon with the new one. But I'm very satisfied with this change, and it works very smoothly, and there is no play at all on the screw. How I was made this, you could see in my videos, and you will have here the link to these videos. Actually, only with the replacing of original electronics was already possible to work with the machine quite well. But as I was used a round table, I was want to place milling head a bit up to have more height for the round table. And that was the reason to get inserts under the column of the milling machine. And now I will unassemble everything here and will show you what I have before and what I have now. Continue unassembling everything. This machine now is much heavier than it was initially. And here's 2 screws with which connected the column to the new cross table that I have. So these are basically the insert about which I was talking, with which I get the possibility to have higher milling space, that all the machine has more space. It's 2 pieces of aluminium and it's just mounted to the column at the moment. Now let's talk about the cross table. These are the original cross table from the Proxxon. It's KT230 cross table, and this one is the original stand of the Proxxon. I was used with this insert, the machine gets higher and everything was fine. But at some day I was found on the Amazon a very good deal for the KT230. This cross table goes together with the stand, so all this part is like one piece. It's made out of steel, because here we have steel on the bottom and completely aluminum cross table. And this cross table is plain if you're trying to mill something stronger than aluminum. So I want to replace this as well. But at this moment, interesting point becomes how to connect milling column from this cross table to this one. And I was made aluminum plate, which I will connect in between of these two cross tables, this one. And now I will remove it and you will see how it's made and what it's for. Initially, this cross table is made for the bigger machine, and it calls Proxxon KT230. No, Proxxon PF 230, doesn't matter. So there is a bigger machine, and the column of this bigger machine is made out of pipe. So it's all the machine connected to the pipe, and this pipe is connected exactly in this place where I have my column connection. So the pipe goes here, and everything connects to this pipe. I was made 4 holes in this steel piece, and let's just connect this piece of aluminum. Here is a lot of holes. I was trying different positions of connection of the column. Also, some of the connections need to be bigger to have more flexibility in the setup. So more or less that's it about the changes and modifications of the machine. Now I will assemble everything together. Now everything is assembled, everything is moving, working, and aligned fine, as it was before. And this machine is ready to go again. That's it for this video. Thanks for watching, and don't forget to subscribe to my channel.